In this particular figure, if we are interested in the calculation of the power, is it right, delivered by the dependent source, and in this case, how will be the formula of the power? This is the voltage. Yes, in this case, if we are interested in the calculation of the power, what values we have to calculate? Here, its formula will be I into R, because this is the DC voltage. Applied voltage is the DC. Formula will be P is equal to V into I. VI. How much is the V? 75 into IA is the V into this I. I may be the current in this branch. Means we have to calculate the value of this IA, because it is dependent, so this is not known, it is required. As well as we are interested in the calculation of current in this branch. Is it right? Suppose if I am giving the names to the branches, in this case, this branch current is I1, this is IA, and suppose this may be the I2. In that case, we are interested in IA and I2, that is the case. Is it right? Now, this is the nodal analysis method. We will follow the procedure as usual, and we will find out the IA and I2, these two currents, and then from these currents, we are able to find out its value, the power delivered by this dependent source to the circuit. In this particular case, if this is the node, it is a node, its potential is VA. This is the ground node. Is it right? Whose potential is 0 volt. Then apply the KCL, that is Kirchhoff's current law, at the node A and find out its equation. Now we will follow the procedure as usual. If even though it has a dependent sources, many times we are thinking about the dependent sources, how it will be, how the equations will be. Don't bother about that. Follow the usual procedure. How is the usual procedure? Apply the KCL at this particular point. How is the KCL? This is the given direction of the current. That's why I have not tried to change it. So here in this case, this is incoming, this is outgoing, this is outgoing. In this case, equation will be, here I will write first, applying KCL at node A. If we are applying the KCL, that is Kirchhoff's current law, at the node A, how will be the equation? Is it right? The equation will be something like this. Equation will be something like this. Equation will be this I1 is equal to IA plus I2. I1 is equal to IA plus I2. How is the value of IA, I1 and I2? We will try to find out these values. Now if we are finding or calculating the value of current I1, which is this branch, 0 plus 80 minus VA divided by 5, that is 80 minus VA divided by 5 is the current I1, which is equal. IA is the current in the vertical branch. How is the equation? VA minus 0 divided by 50. If it is VA divided by 50 is that particular value of the current, which is IA, plus I2 is the current in this particular branch. We will try to find out that value of the current, which is the I2 in this case. So here in this case, we will try to find out that particular value. Is it right? How is that value? In this case, if we are trying to find out the value of the current VA, we are starting from here. This is VA, negative to positive. This is VA plus this voltage, which is 75 into IA minus this potential, which is 0, divided by resistance of both resistance of this complete branch, which is 10 plus 15 is the 25. Are you getting me? If anyone has a difficulty, please raise your hand. I will clarify your doubt. I will calculate the same value once again for this particular branch. Here is the potential VA. VA, we are traveling down. For this dependent source, negative to positive, which is a plus, its value 75 into IA minus this potential divided by resistance of this complete branch, which is 25. That is 15 plus 10 will be the 25, and we will name this equation as equation number 1. If we are simplifying this equation, how it will be? That is 80 divided by 5, it is minus VA divided by 5, which is equal to, it is VA divided by 50 plus, it is VA divided by 25 plus, it is 75 into IA divided by 25. This is the equation. Separate out the terms. What I will do, I will shift this VA to the next side and all constants on the left side, and we will find out its equation. In that case, if we are shifting this VA to the next side, and if we are taking VA as a common, VA in this case inside the bracket, it is 1 upon 5 plus it is 1 upon 50 plus it is 1 upon 25. This is plus 75 into IA divided by 25, which is equal to 80 divided by 5 is the equation. Is it right? Now we will simplify this equation and we will name this equation as equation number 1. Now here I am interested in this calculation and this calculation from your side. Calculate this value and please tell me the answers. I am waiting for your answers. Yes, fine. Yeah, Rishikesh.
Sir, 0.25 VA
Yes, sir.
plus 3 IA
0.25 VA
plus 3 IA
3 into IA
is equals to 16.
60.
No, 16.
This is equation number 1. Now, if student has the answer, yes. Please reply. Yes. Ruchira.
Yes, sir. Correct.
Correct. Okay, fine. Now we will proceed further. But here in this case, how many equations we have and how many unknowns we have? In this case, we have one equation and how many number of unknowns we have? In this particular case, we have the two unknowns. One unknown is VA and another unknown is the IA. Is it right? Now here we have to prepare another equation. Now how is the equation? We have to obtain equation for VA in terms of IA. So here in this case, if we are interested in the calculation of IA in terms of VA, look at carefully. In this branch already we have calculated the current, which is IA. And that value is VA upon 50. Is it right? This equation. Because this is one equation, we want another equation, that is equation for IA only in terms of VA. Already we have obtained the equation for IA in terms of VA, which is VA divided by 50. In this case, this IA is equal to VA divided by 50. Is it right? If we are simplifying this equation, in this case, then here this equation will be something like this. This VA minus 50 into IA, which is equal to 0. This is the equation number 2. Are you getting me? What I have done? I have shifted this VA to the next side. What happened? This will be 50 into IA and I have shifted this 50 into IA on that side, and on this side it will be 0. This VA minus 50 into IA, which is equal to 0. This is another equation. Now we have the two equations and two unknowns. Means what happens whenever we have the dependent source? Generally we have to obtain one extra equation. Then we will go to the one or two more problems. In that particular case, you are able to get the idea about how to obtain these equations. Is it right? Now we have the two equations and two unknowns. Solve these two equations simultaneously and find out the value of VA and find out the value of its unknown, which is IA. Yes. Yeah. I will come back to you. Yes. Is that Saurabh?
Yes, VA value 51.61.
51.61. IA?
IA 1.03.
1.03 amperes. Yes. I will unmute to someone. Rishikesh?
Sir, correct.
Correct. Madhuri?
Correct, sir.
Okay, fine. Now here we know the value of its current and its potential. Now in what value we are interested? In what value we are interested? We are interested in the power calculation. IA is known, VA is known, means we can find out this particular value, this 75 into IA, but I2 is not known. First we will find out the value of current, which is I2. This I2 is equal to, what is the formula for I2? This is I2. This is I2, and in this case formula for I2 is, it is VA plus 75 into IA divided by 25, which is equal to, VA is 51.61 plus, I will take on the next side, this is 51.61 plus 75 into IA is 1.03, which is divided by 25. find out its value of the current, which is I2. How much is the I2? Yes, unmute yourself. Yeah.
5.15.
Sorry?
5.15.
5.15 amperes is the I2. Anyone has the answer? Yes, Rishikesh.
Sir, correct है.
Correct. Now here we know the value of its I2, that is the current. Now here we will try to find out the power. Now in this case, this P is equal to, or power is equal to, or power delivered by this dependent source. What is the formula? V into IA. Its voltage is 75 into IA. Its current is I2. Means it is 75 into IA into it is I2, which is equal to, here this is the 75 into IA. IA is 1.03 into I2, and I2 is that is 5.15, which is equal to, find out the final answer. Yes, Saurabh, unmute yourself.
397.83. 97.
397.83
83.
watt. Anyone? So your answer is yes.
Correct.
Correct. This here 397.83 watt is its value of the power, but whatever the answer I have found in the book, it is 375 watt. It is somewhere we have rounded more values. Both are rounding हुआ है. Maybe here this value is a 0.25 or maybe that value we need to check.